Insertion sort is a simple algorithm that sorts a collection of items one element at a time. As an example, we will sort an array of integers. Let's begin with an unsorted collection here of 6 integers, and we will build our sorted array one element at a time. So step 1, inspect the first element of the collection. Since it's already sorted with respect to itself, we can move on to the next element. The next number we wish to sort is 2. We compare it to the previous number before it, in this case 4. Since 2 is less than 4, we swap the two numbers. And now the first 2 elements of the array are sorted. Step 3, we'll move on to the third item, in this case 1. We compare it to the previous item, and 1 is less than 4. We continue comparing 1 to the previous items in the list until we either reach the start of the collection or find a number that 1 is not less than. Once we find where 1 belongs, we shift the greater numbers up 1 and insert our number. And now we have the first 3 elements of the array sorted. We continue on this way until we reach the end of the array and have inserted each individual element into its sorted position. Six doesn't need to move at all. It stays right where it is. And we'll check the final element and swap it with 6. Now our array is fully sorted. Let's go back to the chalkboard and write some code for insertion sort. I think it helps to whiteboard, or in this case chalkboard, the code, because this is often what you'll be asked to do in a job interview. Let's begin with our original array we wish to sort. Okay, so we have the 6 integers in our array to be sorted. In our solution, we originally looped through the entire array. So we should begin with a for loop that does just that. So let's loop from 0 to 5, which will be the length, which will be keeping I less than the length. But as we found, we don't have to sort the first element in the array because it is sorted with respect to itself. So we don't need to start at 0. Let's start at 1. So we will loop from 1 to 5 here. Next, we will look at the element that we're wishing to sort and write it to a temp variable. This way we can shift the array elements around during sorting and not lose our value. So as we pick each item to be sorted, we need to loop back through the array, searching for items that are smaller than our temp value. So we'll create a new variable, j, and assign it to I minus 1. So we'll be checking the element in the array just before I. Here I'll declare j outside the for loop. Oops. So j equals I minus 1. And I want to search back through the array as long as j is still positive. So we don't want to go outside the bounds of the array. So j has to be greater than or equal to 0. And also I want to stop searching if we find an item that is smaller than our temp value. So we want to make sure that our temp value is still less than each element that we're comparing it to. And if that's the case, we will subtract 1 from j each time and continue searching. And if we find an element that is larger than our temp value, we will shift it forward 1. So xj plus 1 gets what was at xj. And when that's finally finished, we will assign our temp value to where we leave off. So that will be xj plus 1 gets temp. And we say j plus 1 because, as you can see, we subtracted 1 from j after we found the spot where our temp value belongs. Now that we're done with our code, let's go ahead and code it up in Visual Studio. So I'll create a new solution here called InsertionSort App, and we will test our code in this. We'll just do a normal console app for this. Okay. Instead of writing the code in my main method here, I will create a sorting class, an InsertionSort class. And let's see, here we go. And I will instantiate this InsertionSort class to do my sorting for me. So the first thing this class needs is a public sort method that I will call to do my sorting. So I'll return an array of integers, and it will take an unsorted array of integers called collection, and I'll sort it. So let's go ahead and begin to write out the code that we wrote on our whiteboard. So initially we have to loop through our array, starting at I equals 1, if you remember. If I can spell collection here. And we need to save the value that we are trying to sort into a temp variable so that we can shift around the rest of the array without losing it. And we will loop back through the array, searching for items that are greater than our temp value. So we start one element behind I, and make sure that we stay in bounds of the array. And that our temp value continues to be less than the item in the jth position, and subtract from j each time. Now if that's the case, we will shift that element forward, the jth element forward 1. There we go. And once we arrive on the correct position, we will write our temp value to that particular position. And remember, we have to add 1 to j because j subtracted 1 after we found where we wanted to put our temp item, and we'll return that sorted array. And let's not forget to make sure our solution builds. Now that we know our solution compiles, we need to test it. Instead of writing unit tests, I'll go ahead and test it in the main app. So we'll create an InsertionSort class, and we got to define our initial array of integers. I believe that's what we had. And now we'll call the sort method. And instead of printing out our result, I'll simply run this and look in the debugger to see if it in fact gets sorted. So let's run this. And let's look at the sort me array. And 1, 2, 3, 4, 5, 6. Yes, so it did get sorted. So it appears to work. But let's test a few other things first. What if we have an array of, say, just one item? Will it return the same array? Let's take a look. And yes, as you expect, the array remains unchanged. Let's also test an array that's already sorted. Again, it should return the original array. 1, 2, 3, 4. Works perfectly. Now, what about an array with, say, negative values or 0? Let's see if it sorts those as expected. Negative 2, 0, 1, 2, 3. Yes. So it appears to work pretty well with just a few basic tests. And there we have it. Insertion sort from whiteboarding to coding to testing.